Here are the notes for section C-2. We're going to look at parallel lines and a transversal that cuts through them. Last time we met, I showed you these notes. I showed you two lines and then they were cut by a transversal, and we talked about the different types of angles that are formed. Corresponding angles, alternate interior angles, same side interior angles, alternate exterior angles. And I specifically said that these lines don't have to be parallel. So there's no correlation with these angles. But what happens if the lines L and M are parallel? So let's take a look at this diagram. First of all, this little symbol here and here means that the lines are parallel. We already have arrows at the ends of the lines, but we have these two arrows which say parallel lines. So L and M are now parallel, and we still have angles 1 through 8. And then we still have corresponding angles. 1 and 5 are corresponding, 2 and 6, 3 and 7, 4 and 8 are corresponding. But now something important happens. We now have a relationship between 1 and 5, 2 and 6, 3 and 7, and 4 and 8. We have a relationship between the alternate interior angles, 3 and 5, between 4 and 6. We have a relationship now that the lines are parallel. We have the same thing with alternate exterior angles. We have a relationship there, and the same side interior, the 3 and the 6, and the 4 and the 5. What are the relationships? That's what's in these notes. And we'll take a look at the postulate. It's called the same side interior angles postulate. So if I have two lines that are parallel, L and M, a transversal cutting through them, I'm only looking at the interior angles, and on the same side I have 3 and 6 and 4 and 5. What's true about them is that they are supplementary. It says it over here, and it says it over here. The same side interior angles are supplementary only when L and M are parallel. Remember, it's got to be when they're parallel. From that postulate, we've got some theorems. We've got the corresponding angle theorem. When a transversal intersects two parallel lines, then the corresponding angles are congruent. So 1 and 5 will be congruent. 2 and 6 will be congruent. 3 and 7, 4 and 8. They're all going to be congruent. Again, only when the lines are parallel will that happen. The next one is called the alternate interior angles theorem. Now we're looking at the interior angles again. 3 and 5 and 4 and 6. They're going to be congruent to each other. So 4 and 6, 3 and 5, they're congruent to each other. Remember, the same side interior angle said that 3 and 6 would be supplementary. And then there's one more, the alternate exteriors angle theorem. Outside of the parallel lines, we have 1 and 7 and 2 and 8. Those angles will be congruent because of that. So there's one postulate and 3 theorems that you will use in proofs to help prove that some angles are congruent or supplementary. All right, and that's a look at our notes with all of these postulates and theorems, our notes for section C2.